So, I talk about web audio, and the first thing that doesn't work is the audio. Nice. So, let's talk about web audio. I think I have to stand over here so the live stream can capture me. But has anybody of you already played around with web audio or knows what web audio is? Okay, a few. Please don't judge me. I'm just here to have fun. So this presentation, unlike most of the presentations, you'll probably not learn a thing which you can use in your actual job, except for the part then you can also have fun with JavaScript. So let's get started. My name is Sam Bellen. I'm a software engineer at Madewithlove. It's a small company in Belgium. I'm also a Google developer expert, and I organize some meetups in Belgium for frontiers. Enough with this. Let's see what we're going to learn today, or what I will try to teach you or show you. We're going to see five topics. One is how to play sounds on the web. One is how to create sounds on the web, how to compose melodies and rhythms, how to add effects to sounds, and then some live audio with a guitar. So, let's get started. Playing sounds on the web. Who knows this? I think most people already know this and have used it. If you want to play a song on the web, the easiest way to do that is to just create an HTML5 audio element and just pass along an MP3 or a WAV file or whatever file you want. So, how you can play audio on the web? With this. But there's some other ways. The second way is to just do a fetch request or an XML HTTP request if you like the old school version of that. Load a certain MP3 file. And then it gets interesting because then you will have to parse it to an array buffer, then use the audio context, which is available when you create a new audio context in your browser, and then decode that audio, that array buffer to an audio buffer. And then once you have an audio buffer, create a buffer source from it, and connect it to the audio destination. Now I will be talking about the Web Audio API, and there's a few basic things you should know. The first thing is you should always create a new audio context. This audio context is the main foundation of working with the Web Audio API. The second thing is most things you do with the Web Audio API are creating nodes and chaining them together. So here we created a buffer source node, and we connected it to the destination of our audio context, which is basically just the speakers. So what we did was we took that buffer, we created a node for it, and we connected it to the speakers, and then we of course said start. So that's the second way to play audio. I think this is much easier, but if you want to do fancy stuff, you can do it this way. And a third way is to just get your microphone audio, because that's also audio. And the way you can do this is just call the getUserMedia function and say I want audio. Then when this function resolves, you get a stream, and then using that stream, you create a media stream source node and then connect it to the destination, aka your speakers. So that's the third way to get some audio playing in your browser. Easy, right? Are you all still following along, or is it too much code? Now, this talk might also get a bit more technical in some audio theory, but it will be worth it if you just stick along and listen. The second topic I wanted to be talking about is how to create sounds. I'm not talking about loading an MP3 like we did before, but really create sounds with JavaScript in the browser. So let's try it out. I hope that the volume is not too high because this is going to be annoying. We heard a sound, and this might not be an impressive sound because it was just a monotone beep, but it was made with JavaScript in the browser without loading a single file. The way you do this is you have your audio context, like I said, it's the foundation, and then we created an oscillator node. And what an oscillator node is going to do is going to create a sound wave, and then we can use that sound wave later on. But we just connect this this oscillator node to the destination of our audio context, aka the speakers, and we start our oscillator. Now there's a lot of different types of oscillators, like a sine wave. I don't think we have audio on that side, do we? Doesn't matter. You have a triangle wave, a square wave, and a sawtooth wave. Does anybody hear any difference between these type of waves, or is it all the same annoying beeps to you? you might hear a difference because this is a nice, evenly sound, while a square wave is already a bit more distorted and more annoying to listen to. But the main thing I wanted to show you with these examples is that you can create different kind of waves, going from sound wave to sawtooth wave, and it's very easy with an oscillator node. You just create it like we did before, and then as a type you just say sine or square or whatever you prefer. You can also create a custom wave if you're very good in math. I am not very good in math, so I'm not going to do that. And then you set the value of the frequency, and the frequency is just how low or how high a note or a tone should be. The lower the number, the lower the frequency, the higher the higher. The human can more or less hear until 20,000, but if you take 30,000, you can annoy your dog. Don't do that. They will not like it, but it will still work. Then again, we connect it to the destination and start our oscillator. And this is what a sound wave looks like. A triangle wave. You might see that it's a triangle, of course. A square wave, and lastly a sawtooth wave, which is a nice saw. Cool. Now, in this graph, I'm increasing and decreasing the frequency, and you can see how it impacts your wave. The higher the frequency, the more compact your waves will be, the lower, the wider they will be. This might not mean a lot to you, but it's nice to know that sounds are just waves, and your ear does some stuff with it, and your brain does some stuff with it. But we can control these waves, and we can control the shape of it, so we can control the sound. The next thing I want to talk about is linear envelopes. Does anybody know what an envelope is? Except for this paper piece of thing which you put a letter in? One person? Okay. In my previous sound examples, the tone just started and stopped without any going up or down, fading in or out. An envelope is going to let you fade the sound in or out or do other stuff, like so. Still an annoying beep though. But as you could hear, the sound faded in until a certain point and then faded out at the end. And how you can do this is you just create an oscillator and a gain note. A gain note is another type of note you can create with the Web Audio API, and it's going to control your gain or your volume. And then you just use the set value at time and the linear ramp to value at time to control how much or how long it should fade in and fade out. This is how to fade out. I'm not going to leave this code too long on the screen because it's too much, but if you want to have more details, come talk to me after my talk. Now it's good to know that you cannot only just fade in and out the volume, but you can do the same with, let's say, a frequency. And we're getting into a more dynamic sound already. Starting with that first annoying beep, we already have a certain type of, let's call it minimalist techno. So you could hear that the sound did not only fade in and out, volume-wise, but also the frequency went up and down, matter that the sound progressed. It's the same, but instead of doing it with a gain note, you just change the frequency. We talked about linear envelopes. Of course, there's also exponential ones. Instead of going straight up and down, you do it with a nice exponential math function. It's something like this. Starts very slow, goes fast, and then goes away. It works the same, but instead of doing a linear ramp to value at time, you do an exponential. And I think that's the only difference in this function. But combining all of these things, you might be able to create some cool sounds. So let's see how we can compose some sounds. That was not the intended sound, but you could hear a scale going up. Could everybody hear a scale going up? You could. Okay, by combining these a few oscillators and then changing the frequency and the moment they start, you can create scales. I think the speakers cannot handle the web audio. Who did not recognize the song that just played? Yes. So with just some JavaScript, I created this very famous song of a composer, which everybody knows. But you can do other cool stuff, like creating a random song. And it's not very beautiful. But it's created randomly with JavaScript in the browser. And it does actually kind of reminds me of this 56K modems we used to have. Like if you wanted to connect to the internet back in the day, you had this annoying sound. I think that's how they did it. So just by using some the math.random function in JavaScript and then changing some values like a frequency or the duration of a node or their envelopes, you can start to create random songs. Now this is not really useful, but it shows that there's power behind all of these techniques because they're just numbers, and JavaScript and numbers, they're not the best match, but they still work. So yeah, it's easy to compose sounds. So let's have a little look at how you really can do this. As I said, we're just creating a bunch of oscillators. They all have their own frequency, and we're just starting and stopping them at a different time. And then if you just the first one, for example, you start at now. And it's good to know that an audio context has its own clock, because if you do a lot of JavaScript, you might have heard of the call stack and stuff like this, and you just push stuff on it. And if you have some asynchronous calls coming in, certain tasks might get pushed backwards. This audio context clock will just keep on running, and it's very necessary if you want to create a sound, because you cannot wait until play a certain note if suddenly an asynchronous call starts to come in or starts to resolve. So that's why there's a current time value on your audio context. So we start the first one at now, and then we start the second one at now plus 100 milliseconds, and so on and so on and so on. By starting and stopping these oscillators, you can just create a rhythm and a melody. The next one I'm going to talk about is effects, and now we're going to get into a bit more musical theoretical effect kind of thing. But I will demonstrate most of them with the guitar later on, so stick around. The first one is a volume. Now you might not think volume is an effect, but you alter your sound waves, so yeah. As you can see when I click it, the sound wave gets squished down. This means that the volume went down, volume went up. And like I said before, the things you do with the Web Audio API is create nodes and chaining them together. We have our input node, which will be the guitar or your microphone or an MP3 or whatever. We create a gain node, which is just going to control the volume. And then we have the output, which is the speakers, and just connect them together. And then by changing the gain value, you can change the volume. So yeah, that's kind of easy. But, oh, that's what I just talked about. You just create the oscillator, input node, gain node, and then connect it all together and change the gain value. The next one is a distortion one. I don't have a change one. But this used to be a sine wave, but by applying some math on it, I was able to change the wave itself and distort it. And it looks a bit like this. Input, oscillator or guitar or whatever, a wave shaper node and an output. Code looks more or less the same, except for your curve property, you do some fancy math. I'm not good at math, so you can find this on Stack Overflow, for example. Some cool functions. So yeah, I will let you hear it later because this is all a bit abstract, but we're getting there. Next one is a delay, and as you saw, the first two effects were just 3 nodes, input, output, and one in the middle. Now we have a whole bunch of nodes. And what we're going to do is basically take our input, send it to a delay node, send it to a gain node, so it goes back and forth until it fades out, and then also just send the regular audio to the output. And in the end, you'll have a delay effect. Does anybody know what a delay effect is? Are there any guitar players in the room, by the way? Cool. Does anybody want to come and play later? Because, believe it or not, I don't like to play guitar in front of people. I chose the right talk to do. So I'm not going to show you all the code again about creating an audio context and connecting it all together. But the thing you need to know about this delay example is that there's also a delay node which is going to delay your sound with, for example, 1 second. Flanger gets even more complicated, but what you should take away from this is that you cannot only connect nodes to each other, but you can also connect values of a node to another node. So that's all a bit difficult, but by doing this, you will hear that we create an oscillator to really make a dynamic delay, which is going to delay the sound more and less based on the wave of the oscillator. We saw that. And then a reverb, it's just basically going to add some echo or characteristics to your sound. And we use a convolver node for this. So a convolver node is going to load an impulse response file, which is an audio file without audio, but with some characteristics. And by using this audio file with a convolver node, you will be able to project those characteristics, like for example, a large room or a small bathroom. You might know that you have a different kind of echo in those rooms. So you project those characteristics onto your audio, like so. And there's a bunch of other nodes where I will not be talking about because there's too many to just talk about. I'll just mention them quickly. An analyzer node lets you analyze your audio. You might have seen on my first slide there was the graph going up and down when I talked. I used an analyzer node for that. A B-quad filter node is to filter out some frequencies. A channel splitter node to split your audio into, for example, from mono to stereo. Merger, other way around, stereo to mono. Panner, going from left to right, or if you have Dolby 7.1 or so, you can position your audio all over the room, and then a compressor node is going to compress your audio. So I just showed you how to create these effects, but they all have a lot of nodes, and they're kind of technical, so I created a little library where you can just say, I want a distortion, add it to your chain, and then it works. Just as a little bit of information, I wanted to mention this. But what about debugging? Because how do you debug web audio? Firefox has some developer tools for this, which is very nice. Does anybody use Firefox? You're brave. I'm using Chrome at the moment, but I do like Firefox. So if you want to play around with the Web Audio API, it's nice to use Firefox because they have developer tools. There's also a non-official developer tool for Chrome, but it's not as good as this one. So here you can perfectly see the chains of nodes you make. You can inspect all the values you gave to the properties. So it's useful. So let's get to the real and interesting part, live audio. I created this little website called pedalboard.sambiga.be. You can all try it at home if you want. You can also do it with a microphone, so you can add these effects to your microphone, as long as it's not the built-in microphone of your laptop, because you'll create a feedback loop and it will sound like noise. So yeah, let's try. That was some kind of noise. This is what I mean with the feedback loop. All right, let's try again. Yeah. So what I just did is I connected this guitar to my computer with a little box, but that doesn't matter. In essence, my guitar is now my microphone. So this would work the same with any kind of microphone you have, like on a headset, for example. So my guitar is a microphone. I created an input node out of it. I connected it to the destination of my audio context, my speakers, and by doing this, you have some kind of guitar sound. Now, if I add a volume one, it's not very special because you might guess you cannot hear it anymore. The volume is down. So let's skip that one and go straight to the distortion. Now, if I play the guitar now, you might hear that it's a bit more distorted, and it should sound like a guitar sound. So you can hear that there's a big difference. Can you hear that there's a big difference between this and the previous sound? Because I see you guys looking, but I'm not sure if it's really working. So by just creating this wave shaper node, I alter the shape of my waves, and you get, for example, a distortion effect. Next one, a delay, and yeah, wait. You hear it echoing on and delaying and fading out. Of course, you can change some parameters like the speed and stuff like this. It's not still. That's too fast. For example, you can change the speed of how fast it iterates or it fades out and how long it will take. So that's a delay effect. The next one is a flanger. And if you ignore the quality of the sound, you might hear that there's a wavy sound in the background of it. You might hear it if you're lucky. I can hear it. And that's a flanger, which is basically just an oscillator which is going to control the amount of delay in this flanger, so it's going to be longer and a shorter delay. Next one is the reverb, and let's hope we can hear this, because this is going to add a bit more of echo to this sound, and it's basically going to project some characteristics on my guitar. And the last one, this one should be audible as well. It's a tremolo. And if you put this up, you can hear it going up and down and up and down. And basically, this is also using an oscillator to control your volume. I'm really sorry for the quality of the sound, but we just created some effects with JavaScript and added it to a live guitar, which I think is really cool. Do you think it's really cool? Thank you. As I said, I don't like to play guitar in front of people, so I'm not going to do the craziest solos. If somebody else wants to do that, go ahead. But we're not done yet, because this is the web, and why shouldn't you use the web, what it's made for? To let other people add effects to the guitar I'm holding right now. So if you all take your phone and go to this URL, you can add some effects to the guitar while I just play one chord or a few chords, and in the end we'll get noise. It's just, it's the web, so why not play around with it? Let me quickly, I'll show it to you in 1 second. Does everybody know the URL, or do you have to keep it? And we already have a few people. So now you can just choose. And in the end, it will just get super noisy, because too much noise is a bad idea. So let's call this performance art. But yeah, we're working with a browser, so why not do some funny stuff with this? Excuse me? Okay. Another thing I once started to create, and it never got finished, is a synthesizer. You get the point, right? That's how they make industrial music. So by just adding a bunch of oscillators together and some keyboard stuff, you can start making cooler stuff like synthesizers or guitar effects. And this is all without using one single audio file. It's just JavaScript. And I think that's pretty cool. Let's see what else I have to tell you. That's it. Here's some few links. So if you're interested in that audio library, it's there. If you want to learn how to calculate the frequency, it's there. If you want to create an oscilloscope, also there. And then the pedal board, if you want to play with it at home, pedalboard.sambiga.be. Just don't use your built-in microphone of your laptop, but use a headset or a guitar or whatever you have, a keyboard, and you can add effects to whatever you want. Thank you.
So I didn't see any questions, only an awesome performance art on our Twitter wall with the hello FronCen. But my question is, how do you record this stuff? For example,
well, you also have another API which is called the Media Recorder API, which you can just give a stream and then records any media in your browser.
So basically, you can make music totally from start to finish with JavaScript.
Lo-fi, but yeah, you can make music in your browser.
Yeah, that's totally awesome. Okay, thank you.
There's another question.
So you showed that you can get audio from your microphone, but what about applications? Is that possible?
Well, if you would create a virtual input on your laptop from that application, sure. The thing is, the get user media is going to access your microphone and your webcam if you're interested in it, but that's another talk. So any input device you select as your input device in your Chrome. So right here you can select input devices. For example, I have a virtual one to record my audio on Chrome. If you would create a virtual input device from Ableton or whichever software you would like to use, yes, you can.
Any other questions I missed?
One in the back.
Hi, have you had some experience integrating with audio API with WebRTC technology to make some online bands playing or something?
I have not, but there is a really good talk about that, I think from JSConf in 2014 or 13, where they do a live band practice on stage with somebody on stage and then a few people at their homes with WebRTC and stuff like this. So there's a cool talk about that if you're interested in that.
Any other questions? We have still a minute and a half.
Let's get something to drink then.
Yeah, going once, going twice, 3 times. Thank you.